Welcome back, math friends. Today we're taking a look at Introduction to Functions. That's lesson 1.7 in our math. So make sure in your math notebook write lesson 1.7 at the top. Make sure to copy Introduction to Functions. And remember, anytime you need to pause the video to get caught up on your writing, please do so, because it's more important to get everything written down than it is to hurry through. Okay. So let's take a look now at the important vocabulary here. What is a function? The definition of a function is it's a rule that establishes a relationship between two quantities called the input and the output. Those quantities are called the input and output. Now, if it's a function, for each input, this is super important, for each input there is exactly one output. But more than one input can have the same output. So let's look over here at this diagram. Please copy down the diagram. Here are our inputs and here are our outputs. Now notice for the input of 0, the output is 3. That's just one output, so that's good. For the input of 1, it has the output of 1. That's good. For the input of 3, it also has the output of 1. And that's okay, because remember, the rule is every input has to have only one output. And it does. It's the same as this input's output, but that's all right. And 4 has an input of 2. So it's important to remember, especially this part of the definition, okay? Now, making an input-output table is one way to describe a function. Now, this table here shows the inputs and outputs from this diagram. Here, input 0, output 3, input 1, output 1, input 3, output 1, input 4, output 2. This is an input-output table. It's important. Copy it down. Label it as an input-output table. Okay? Another important definition is the domain. Now, the domain is important because it is the collection of all the possible input values of the function, all the input values. So the domain of this function that's up above, the domain is 0, 1, 3, and 4. How do we know that? Because here are our inputs, 0, 1, 3, and 4. Those are the inputs. So those are that's the domain, a list of all the possible inputs. Now, the range is the collection of all the possible output values. So if we look at our outputs, there are 3, 1, 1, and 2. But we don't need to write the ones twice. So the range of the function is 1, 2, and 3. Notice that the domain and range are written in numerical order. That is perfectly fine. Now, let's look at making an input-output table. Okay? This diagram shows the first 6 triangular numbers, 1, 3, 6, 10, 15, and 21, which continue on the following, and the same way in the pattern. Now, we can create the input-output table. Input, output. All right? In figure 1, the output is 1. In figure 2, the output is 3. And when the input is 3, that's the third figure, the output is 6. When in the fourth figure, the output is 10. In the fifth figure, the output is 15. In the sixth figure, the output is 21. And if we were to continue, the seventh figure, we would add, well, I'll let you figure that out, but the next number would be 28. Okay? So, that's our input-output table. Does this table represent a function? Well, does every input have exactly one output? Yes. Yes, it does, because here, 1, 1, 2, 3, 3, 6, 4, 10, 5, 15, 6, 21, 7, 28. Each input has only one output. Okay? Now let's talk about the domain and the range. So the domain of this function, That's a list of all the inputs. Fancy bracket, 1, 2, 3, 4, 5, 6, 7, and so on. Those are all the possible inputs. The range is all the possible outputs. The outputs are 1, 3, 6, 10, 15, 21, and 28, and so on. Domain and range, inputs and outputs. Okay? Now let's take a look at some tables and see if they represent functions or not. So here's our first one. Our inputs are 1, 2, 3, and 4. Our outputs are 3, 4, 5, and 6. Input of 1, output of 3. Input of 2, output 4. Input 3, output 5. Input 4, output 6. Does every input have only one output? Yes. So that's a function. How about the next one? Let's see. The input is 1, the output is 3. The input is 2, the output is 3. Whoa, what's going on? Don't worry, that's still a function. Even though the input of 3 has an output of 4, the input of 4 has an output of 4. Does every input value have exactly one output? Yes. It's okay if they share the same output, that's fine. You just have to make sure that every input has only one output, and that's true. So yes, that's a function. How about this one? Well, let's see. Input of 1, output of 3. Input of 1, output of 4. Whoa! Whoa, hold on, stop. Look, already we know this is not a function, and here's why. When the input is 1, output is 3. Input 1, output 4. 1 and 1, that's the same number, right? That's still just 1. But 1 has 2 separate outputs. Not okay, not a function. Okay? Not a function. Important for you to remember that. Don't forget. Now, let's imagine you're in a hot air balloon. We're going to be writing equations for functions. Imagine you're in a hot air balloon at an altitude of 250 feet. You're starting at 250 feet. Then you turn on the burner and rise at a rate of 20 feet per minute for 5 minutes. Now your altitude, h, so how high you are off the ground, is a function of the number of minutes for a maximum of 5 minutes. Okay? So let's take a look here. Here's our verbal model. We know that our final altitude is going to be equal to our starting altitude plus the rate of change in altitude multiplied by the number of minutes that we're increasing our altitude. So if we label these, the final altitude, we don't know what that is. We're going to call that h, and that's in feet. The starting altitude is at 250, and that's in feet. The rate of change in altitude is 20 feet per minute, and the number of minutes, well, we don't know. That's t. That changes, right? That varies. And that's in minutes. So here's our algebraic model now. Your total altitude is equal to 250 plus 20 multiplied by the number of minutes, where t is greater than or equal to 0 but less than or equal to 5. So we can graph this function. Make sure you're writing all this down, please. Graph this function and make a table first. So here's our table. I've already put part of it in here. So if we look, here are our inputs, the number of minutes. Here's our function, 250 plus 20 multiplied by the number of minutes. I'm going to fill in the outputs, and you can see how the outputs changed with every increase in minutes. 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes. This is where our final altitude is. Now we can take this information and we can put it into our graph, and I'm going to do that right now. Now you can see in the table, or the graph, the graph, that for every minute that the time goes up, the altitude of the balloon goes up. And because it's at a constant rate, 20 feet per minute, it's going to be following in a straight line. And so we can predict where it will be at certain numbers of minutes. Okay, so we've got our function table and we have our graph of the data. So that's very good. So just a brief introduction to functions. Remember, for it to be a real function, every input has only one output. So here are the practice problems. There aren't that many. You can pause this or you can go back to the slide where the video was and click on practice and it'll show you these problems and you can copy them down from there or print it off. Hey, have a great day. Don't forget to be awesome. We'll see you next time.